Howdy, math neighbors. It's me, friendly neighborhood mathematics teacher, back with another video. This time we're looking at factoring quadratic trinomials. So a trinomial means something with three terms. We have here something that's three terms. We know it's quadratic because the highest exponent or degree is 2. And we would like to factor this. So if we think about what it means to factor something, we want to break this thing down into stuff that multiplies together to make this original stuff. And that's what we're going to endeavor to do. And in order to do that, there's three really important skills that we need to make sure we've got in the forefront of our brain. One of those skills, and these are in no particular order, is diamond math. Second one is knowing how to factor out a GCF, and the third one is knowing how to factor with grouping. So if we know those three things and a couple of other little tricks, we'll be able to make the magic happen here. So the first thing that we want to be thinking about when we're factoring is how I'm going to be changing this trinomial, but not everything in that trinomial. I'm going to be keeping the 9n squared and the positive 8 the same because those are perfectly fine. What I need to do is take this 18n and I need to change the way 18n looks in such a way to where I can group. Now, if we're fresh on remembering grouping, we know that we're going to need 4 terms. So I got to come up with the 2 terms that 18n is going to be split up or broken down into. And those 2 terms come from diamond math. So when we're doing diamond math, we set up our puzzle by looking at the number 72 and the number 18. So what we're doing is we're coming up with numbers that multiply to make 72 and add to make 18. And if you're not sure how to do that, then what I suggest doing is just starting out with a number and then doing 72 divided by 1 and seeing what you get. Starting with another number after 1, 2. Doing 72 divided by 2, seeing what you get. And do that until you've got 2 numbers that you're going to be able to add together to make 18. In this case, it's going to be a positive 12 and a positive 6, because 12 times 6 is 72. And if I add 12 and 6, I get 18. So I have 9n squared plus 12n plus 6n plus 8. And now I've got grouping. So if I look at my first 2 terms, 9n, n is raised to the power of 2, and 12n, I have a greatest common factor of 3n. Left over inside the parentheses are the results of dividing 9n to the second by 3n. The result is also 3n. And 12n divided by 3n is 4. Now for the next 2, 6n, and 8, I need a greatest common factor. That's going to be a positive 2. And if I do 6n divided by positive 2, that goes first, and 8 divided by positive 2, that goes second. That's 3n and plus 4. Now what we know from grouping is once we have these the same, I can factor those out of the first term, and then I have another set of remainders. This time it's the 3n and the positive 2. Now we're not going to do it today. This will be a future endeavor, but you can check that by using the distributive property, whichever of your favorite graphic organizers applies, and then getting the result. And after doing that and combining like terms, you get back to the original 9n to the second plus 18n, or plus 18n plus 8. And honestly, we could factor all day. We could keep going forever and ever. So we're going to check this one out. This one has a first term of a to the second, a second term of a, and a third term of 90. I don't want to factor that one completely. Oh, you may be wondering how I got 72, because there's no 72 in here. Where did 72 come from? So that 72, that's one of those tricks I was mentioning. 72 comes from doing the 9 times 8. So do you remember those two terms that we didn't change? The two terms you don't change, the recopied terms. If you multiply the number parts of both of those terms, in the first term, 9n squared, 9 is the number part, the coefficient. And the third term, 8, is just all number. If you multiply those together, you get 72. So that's how you get the 72. Drawing our attention to this second one, we have an a squared plus a minus 90 again. We would like to factor that completely. And when I'm factoring a trinomial, I'm thinking about diamond math and factoring out greatest common factors and factoring with grouping. And there's one other thing. Remember, in order to do the diamond math here, I had to get this number, the top of my puzzle. Okay. So before we get to diamond math, let's remember, what are the things that remain the same? Things that remain the same are the a squared and the negative 90. I'm not changing those at all because I don't need to. They don't help me factor. And my puzzle has negative 90, which again is the number part here and the number part here, the two things I don't change. And then I need to add to equal 1. Where did 1 come from? That's the coefficient of a. Remember, I am decomposing 1a, or breaking 1a up into constituent numbers, numbers that add to make 1. Now, I can't just choose any such numbers. I need to choose numbers that multiply to make negative 90. So if you're stuck on the numbers, like you just can't come up with it, again, take a number like 1, do 90 divided by 1 on your calculator, gives you 90. Do 90 divided by 2 on your calculator. That gives you 45. 90 divided by 3 gives you 30. 90 divided by 4 doesn't work. 90 divided by 5. So you do that, and you do that, and you do that until you get to two numbers that add to make 1 and multiply to make negative 90. In this case, positive 10 and negative 9 will do the trick. And then I take positive 10 and negative 9, and I write those in place of 1a. Now that I have 4 terms, I can group. Greatest common factor of a leaves behind a plus 10. Sorry, that 9 looks like an a, I apologize. Factoring negative 9 out leaves another a plus 10, as those quantities are the same. I can factor those out to finish the grouping to have a minus 9. We're going to do that second, actually. And a plus 10, we'll do that first. Cool. How about a few more? I deliberately left off the word completely. That was not a mistake. All right, so I'm looking at this quadratic trinomial. I know that when I'm factoring the 4v squared and the negative 28, they remain the same. What I need to do is figure out two numbers that are going to add to make negative 9. And then they're going to multiply to make negative 144. How did I get negative 144? Remember, negative 144 comes from multiplying these two together. Okay, so if you have no place to start with, you could just start with 1 and say 144 divided. Okay, so that didn't do it. 2 and 72. Okay, because 144. Okay, I could go right to 12. I could say 12 and 12 and be like jumping ahead. But the main thing here is, and what you don't want to do is keep repeating yourself. So you don't want constantly to be going back and forth and saying, okay, did I do 2? Not, yes, not, yes, no, maybe. I don't know. What did I do? Did I do 2? I think it's helpful to write it down. All right, so we're trying to do negative 144. What's going to work for negative 144? Well, 6 and 24. Oh, but that doesn't add to make negative 9. Whatever could I use? I don't know. I'm gonna have to think about this for a hot minute. You know, I thought about it for a hot minute, and I thought about it for a hot minute, and I couldn't come up with anything. So I was like, oh, this doesn't factor. Oh, but no, wait, it does. Because 4 times 28 is negative 112. How about that? Always make sure you double check your calculations with your calculator, right? So negative 112 and negative 9. If I do a negative 16 and a positive 7, that'll do the trick. And I can group. I can take out a v and get 4v plus 7. I can factor out a negative 4 and get 4v plus 7 again. Now, these don't always match. I know that they matched because I did 16v divided by, I'm sorry, negative 16v divided by negative 4 to make positive 4v, and negative 28 divided by negative 4 to make positive 7. So as I was trying to illustrate for you, if you get something that's not working, go back and check your work from the beginning. So like here, I made the deliberate mistake of saying 4 times 28 is 144, and it's not. Regardless, to finish grouping, I can factor out the 4v plus 7 to leave me with a v minus 4. We're going to continue with another one here. So notice how I've already written out the diamond math. I keep the 8t squared and the negative 3 the same. And I multiply the 8 and negative 3 to make negative 24. And then I need numbers that multiply to make negative 24 and add to make negative 2. In this case, negative 6 and 4. That's a negative 6t plus 4t. And then I group 2t, greatest common factor here. 8t to the second divided by 2t leaves me with 4t. Negative 6t divided by 2t leaves me with negative 3. From 4t and negative 3, I factor out a 1. Sneaky. And I have a 4t minus 3 times a 2t plus 1. Let's do a few more together on this fine day. Okay, so that's our new one. We're factoring a trinomial. And in order to factor a trinomial, I think to myself the same things I've been thinking. Diamond math, greatest common factor, grouping. And I'm looking at 9t squared. I'm looking at 9x squared. I'm looking at 21x. I'm looking at negative 8. And I'm thinking to myself, how is this going to work out? What are the factors going to be here? So the 9x squared and the negative 8, those are always the same. Where do I get negative 72 from? I get negative 72 from doing the ones that don't change. And then I need to add to make the positive 21. And then I go through it. If I can't think of it right away, like I'm like, oh, 8 and 9 are 72. Oh, but 8 and 9 don't make 21. I'll write down that I used 8 and 9, so I don't try to use those again. Okay, what else? 6 and 12, that makes 72, but that's not going to make 21. What's it going to be? That's what I have to figure out. Ends up being a positive 24 and a negative 3. So plus 24x minus 3x. Now shifting gears, since I have something I can group, I do the greatest common factor of 9x squared and 24x. That's 3x. Then I do 9x squared divided by 3x. That goes first. That is also 3x. Then I do 24x divided by 3x. That's a positive 8. Here, I have a negative 1. Factoring negative 1 out means negative 3x divided by negative 1. Negative divided by negative becomes positive. Negative 8 divided by negative 1, same thing. Negative 8 divided by another negative 1 leaves me with a positive. So I have matching binomials, or matching things inside the parentheses. That's a 3x minus 1 times the quantity of 3x plus 8. Cool. Cool, cool. Cool, cool, cool. Five p squared minus p minus 18. That's our next one. Now, something that's really important in math is you want to have a plan in mind before you start. And sometimes what you need to do to have the plan in mind before you start is just think about, okay, what are the math things I'm going to use? And if you're factoring a quadratic trinomial, actually, that's probably the first place we start. We start by recognition. We recognize that we have something with 3 terms and it's quadratic. Quadratic trinomial, we can factor this. How are we going to factor this? With grouping, but it's not 4 terms. Not an issue because I can use diamond math to take care of that. So I need factors of negative 90 that add to make negative 1. What are those going to be? Those are going to be a negative 10 and a positive 9. So 5p squared and negative 18, those are the same, which is where the negative 90 comes from, 5 times negative 18. The negative p is gone, that's replaced with negative 10p plus p. I factor a 5p out, which gives me a p minus 2. Oops, helps if you write it correctly, 9p. I factor a 9 out, p minus 2. Those match, I factor p minus 2 out, and I have 5p plus 9. This is your friendly neighborhood mathematics teacher signing out. Peace.